professional. Everyone says Nvidia won because it made better chips. But the real reason is more unsettling. It built the layer AI would eventually depend on before most of the world understood that layer even mattered. That is the part many people still miss. When most people look at Nvidia, they see the visible product. They see the GPU. They see the black boxes inside data centers, the soaring demand, the explosive revenue, and the image of a company that just happened to be standing in the right place when AI arrived. It is a clean story, a simple story. Nvidia made faster chips. AI needed faster chips. Nvidia got rich. But that story is too shallow to explain what really happened, because better chips alone do not create inevitability. Better chips can win a product cycle. Better chips can create a temporary lead. Better chips can even make a company look dominant for a while. But product leads are fragile. They can be challenged. They can be benchmarked. They can be replaced. What Nvidia built was much harder to replace. It did not just build a superior component. It built a dependency layer. It built the environment that AI researchers, cloud platforms, startups, and enterprises would eventually have to move through whether they plan to or not. And that difference changed everything. To understand Nvidia, you have to understand Jensen Huang's philosophy, not just his engineering discipline, but the way he thinks about markets. Huang did not build Nvidia as a company that merely ships hardware. He pushed it toward becoming a company that defines a computing era. That sounds abstract, but the business logic is actually simple. If you sell only a chip, then customers compare you to another chip. If you build the architecture, the software, the tools, the libraries, the workflows, and the developer habits around that chip, then customers are no longer choosing a part. They are entering a system. That was the deeper game. In the early years, Nvidia was not an AI company in the way people think of it now. It was fighting to survive in graphics. That market was brutal. Performance mattered. Cycles were short. Competitors were everywhere. A company could look strong in one generation and suddenly look replaceable in the next. That environment taught Nvidia something foundational. Hardware leadership without ecosystem leverage is fragile. A faster product is useful, but not enough. If the rest of the world can switch away from you easily, then your lead is always under attack. So Nvidia learned, early and painfully, that the real challenge was not only to build a great chip, it was to build a reason for the world to stay. That lesson shaped the company's instincts. So when Nvidia began pushing GPUs beyond graphics and into general-purpose computing, it was not just chasing a new use case, it was trying to redefine what the GPU was. This was a philosophical move as much as a technical one. Most companies wait for demand to become obvious before they commit seriously. Jensen Huang repeatedly pushed Nvidia in the other direction. He was willing to invest before the market looked fully real, as long as the technical direction seemed inevitable. That is a very important difference. He was not asking, is this market already here? He was asking, if this becomes real, what will the world need before it can scale? That is how you get a company that spends years building for a future that most of the world still treats as optional. And that future had a name: accelerated computing. Accelerated computing sounds like a technical phrase, but it is actually a strategic doctrine. The doctrine says that the old model of computing, built mainly around the general-purpose CPU, would eventually become too inefficient for the world's most demanding workloads. Graphics was one proof point. Scientific computing became another. Then machine learning entered the picture. In each case, the pattern was similar. Once workloads became massively parallel, traditional architectures began to look slower, less efficient, and less economically rational. The future would not belong only to the most flexible processor. It would belong to the architecture that could handle scale, parallelism, and performance density more effectively. Nvidia did not just notice that shift, it organized itself around it. That is where CUDA becomes central. CUDA was not just a software release. It was one of the most important strategic decisions in Nvidia's history, because CUDA changed Nvidia from a chip vendor into a platform builder. Before CUDA, the GPU was still largely perceived as a specialized piece of hardware. Powerful, yes. Important, yes. But still something that sat inside a narrower technical box. CUDA changed that by giving developers a direct way to program the GPU for broader computational work. That mattered because developers do not commit to hardware in the abstract. They commit to tools, documentation, libraries, workflows, community knowledge, and habits. Once you teach the world how to build on your architecture, you are no longer only shipping silicon, you are shaping behavior. That is where Jensen Huang's business philosophy becomes especially clear. He understood that the most powerful infrastructure is the infrastructure that feels natural by the time everyone needs it. The winning move is often invisible until the dependency is already there. CUDA did not look glamorous to the mass market. It did not create the emotional reaction of a new consumer device. It did not instantly make Nvidia look culturally dominant. But it quietly trained a generation of developers, researchers, and engineers to think inside Nvidia's environment. That is how hidden systems work. They do not announce dominance, they normalize it. By the time deep learning began to break through in a serious way, Nvidia had already laid down years of groundwork. Researchers did not just need raw compute, they needed frameworks, compatibility, optimized libraries, developer support, predictable performance, and a path from experiment to scale. That path increasingly ran through Nvidia. This is why the company's advantage was bigger than better chips. If the only advantage was speed, competitors could close the gap by designing faster hardware. And some did improve. Many still are. But when the real advantage includes compilers, libraries, cloud integrations, inference stacks, training systems, developer habits, networking, and an installed base of people who already know how to work inside your architecture, then the battlefield changes. Competitors are no longer trying to beat a product, they are trying to replace an operating environment. That is a much harder war. This is also why Jensen Huang's leadership style matters so much to the story. He has long behaved like someone who believes difficult things become strategic assets precisely because most competitors avoid them. Nvidia repeatedly chose complexity where others preferred simpler stories. It did not stop at designing chips. It kept climbing the stack. It built developer tools. It optimized software. It invested in systems like DGX. It moved into networking. It pushed deeper into inference. It expanded into simulation, robotics, autonomous systems, and enterprise AI workflows. Many people describe this as aggressive expansion. The more precise phrase would be strategic enclosure. Nvidia kept reducing the number of critical layers it did not influence, and that made the company harder to root around. That is why the AI boom made Nvidia look inevitable, not because the future randomly selected one lucky winner, but because when the demand shock finally arrived, Nvidia was already standing at too many strategic intersections. If you wanted to train models, Nvidia was there. If you wanted to rent compute through the cloud, Nvidia was there. If you wanted mature developer tooling, Nvidia was there. If you wanted optimized performance libraries, Nvidia was there. If you wanted system-level hardware designed for AI workloads, Nvidia was there. The company had positioned itself not at the edge of the AI stack, but inside its bloodstream. That is a very different kind of power. Most people also misunderstand timing. They think Nvidia predicted AI perfectly. That is too neat, and it makes the story feel almost magical. The better way to understand it is this: Nvidia spent years building a general infrastructure for hard computational problems, and AI later became the biggest and most commercially explosive expression of that bet. That distinction matters. It shows the difference between betting on a trend and betting on a structural shift. Huang was not building for one app. He was building for a world in which more and more valuable problems would become compute-bound, data-heavy, and massively parallel. AI simply became the force that made that world impossible to ignore. And once that happened, the hidden system became visible. The chip at the center of the story was real. Of course it was. Nvidia's hardware execution mattered. Its engineering pace mattered. Its engineering pace mattered. Its performance per generation mattered. But hardware was only the visible face of a deeper architecture. The real moat was coordination. Years of aligning silicon, software, developer behavior, enterprise adoption, research incentives, and cloud infrastructure around a single gravitational center. That is why so many smart companies found themselves depending on Nvidia faster than they expected. They were not just buying performance, they were buying time, they were buying compatibility, they were buying reliability, they were buying access to a mature ecosystem. They were buying the confidence that what they built today would still run, scale, and improve tomorrow. In fast-moving markets, those things are often more valuable than the theoretical possibility of a cheaper alternative. This is another lesson from Jensen Huang's philosophy. He has consistently treated speed not only as benchmark speed, but as customer speed. The deeper question was never just, how do we make a faster chip? It was, how do we make it faster for the world to do useful work on top of our infrastructure? That is a much more dangerous question, because once a company helps customers move faster, build faster, deploy faster, and learn faster, it becomes embedded in their momentum, and embedded momentum is hard to unwind. There is also a cultural point here that matters. Nvidia developed a reputation for intensity, long-range conviction, and extreme execution pressure. Huang often appears calm and highly articulate in public, but the company underneath has operated with deep internal urgency for years. That matters because building invisible infrastructure before demand becomes obvious is expensive, lonely work. It requires conviction during periods when the payoff still looks uncertain. Many companies say they think long-term. Far fewer are willing to suffer years of ambiguity, skepticism, and uneven recognition while paying the cost of that belief. Nvidia did, and that willingness created asymmetry. While others were still seeing AI as one interesting application area among many, Nvidia was already acting like it was building a foundational computing layer for the next era. Once AI crossed from research curiosity to industrial race, that groundwork started compounding with enormous force. That is why visible product versus hidden system is such a powerful way to understand Nvidia. The visible product made the company famous. The hidden system made the company unavoidable. The visible product is what headlines talk about. It is easier to photograph, easier to compare, easier to benchmark, and easier to explain in one sentence. But the hidden system is what shapes markets. It decides who can scale, who can prototype quickly, who can move from model demo to deployment, and who gets trapped rebuilding the stack from scratch. In major technology waves, the strongest company is not always the one with the hottest object in the moment. More often, it is the company that quietly built the rails, the tools, the default workflows, and the operational environment that everyone else must eventually use. Nvidia became that company for AI, and perhaps the most unsettling part is that this was not purely a story of reaction. It was a story of preparation. Huang and Nvidia did not wait for the whole world to declare AI the future before building the system. They built first. They invested first. They trained the ecosystem first. They accepted years in which the outside world only partially understood the bet. And then, when AI finally became commercially explosive, the world discovered that much of the path had already been paved. That is why inevitability can look sudden from the outside. A company seems to appear out of nowhere and dominate, but the dominance usually arrives late. The infrastructure work happened much earlier, when the market was still distracted by more visible products, cleaner narratives, and shorter-term opportunities. So what is the real lesson here? It is not simply that Nvidia had better chips. It is that Jensen Huang built the company around a harder and more durable idea. If a technological wave is coming, do not just build the product it will use. Build the layer it will depend on. Build the tools people learn on. Build the systems enterprises standardize on. Build the environment researchers publish in. Build the workflow the cloud adopts. Build the default, because once you become the default layer of an emerging era, demand stops feeling like a sales win. It starts feeling like gravity. And that is what made Nvidia so powerful when AI exploded. The market did not just choose Nvidia in a moment of excitement. It discovered that Nvidia had already spent years making itself the most natural path forward. That is a much deeper kind of victory. The strongest company is not always the company with the hottest product in the moment. Often it is the company that built the infrastructure layer the later boom is forced to pass through. That was Nvidia's real advantage. It was bigger than better chips. It was built before AI. What other companies do you think look dominant on the surface, but are actually winning because of a hidden system underneath? Let me know in the comments. And if you want more business stories told to strategy systems and the deeper logic behind market power, subscribe for the next episode.